2.5 is a little bit of a tricky section. There's so much writing in section 2.5. So the notes that I have here for you do have all the writing done already. I just think it will be clearer and easier to see, but I'll still go through everything. So we start off talking about conditional statements. What's a conditional statement? Well, a conditional statement, it has a condition. If this happens, then this will happen. If we have a giant snowstorm, then we won't have school, right? Something like that. Or I have as the example, if I do all my homework, then I will get a good grade. So it's an if-then statement. Or we use the letter P to describe the if, and the letter Q, lowercase, to describe the then. So sometimes a conditional statement is described as P implies Q. The P is the hypothesis. So the hypothesis comes after the if. And a lot of times we single underline the hypothesis. If I do all my homework, the I do all my homework single underline here is the hypothesis. So if I go back to here and kind of not underline the if. And then whatever comes after the then, that's the conclusion. That comes after the then. So then I will get a good grade, and we usually double underline the conclusion. So first we give us a couple conditional statements. We single underline, double underline. It's done for us, but we'll still go through it. If a polygon has 3 sides, notice I'm not underlining the word if, then it is a triangle, double underlining. Notice that the words if and then do not get underlined. And that's true, by the way. If a polygon has 3 sides, then it's a triangle. If 2 angles are vertical angles, then they are congruent. 2 angles are vertical angles is the hypothesis, the P, if you will, and then they are congruent is the Q. So here, sometimes things aren't written always in an if-then form, so maybe we have to rewrite them. So originally this number 3 says an angle is obtuse if its measure is 170. We rewrite that in if-then form. In other words, if an angle measures 170, then it is obtuse. Same sentence, just rewritten in an if-then format. Number 4 says a number divisible by 6 is also divisible by 3 and 2. If we rewrote that, we would say if a number is divisible by 6, then it is also divisible by 3 and 2. So just like a slight difference there. So those are conditional statements, if and then. Then we talk about different kinds of reasoning. So we're going to have 2 types of reasoning, inductive, deductive. Inductive reasoning here is based on a pattern. Deductive is based on fact. So what do we mean by that? Like a pattern might be like, it's Tuesday, there's a pizza for sale at the church across the street. It's Tuesday again, pizza again. Tuesday again, pizza again. And then you might be like, hey, wait a second, it's Tuesday, I bet there's pizza, right? That's a pattern that you're seeing. Fact is more like, that shape has 3 sides, therefore it's a triangle. Like undisputable fact, 1000% of the time it is always true, right? Versus a pattern, which may be true for a while, but like we don't have Tuesdays mean pizza over the summer. Okay, so, and you can't read too much into this. So here they, kind of like that idea of getting a little conclusion and then saying, is this based on fact or a pattern? So we kind of circle inductive or deductive. So number 5 here comes with my example here. The church serves pizza every Tuesday. If today's Tuesday, therefore pizza will be served. And we said that that was inductive, following a pattern. The next one, if it's noon on Monday and the children are in school, it's kind of a fact, right? Noon on Monday, therefore the children are in school. Oh, wait, I said inductive. That's one of those, it could probably go either way, but probably Monday, noon, it's kind of like the Tuesday's pizza. And by the way, I don't ask you for the inductive or deductive on the test because it's too hard to tell sometimes. So I might ask you for the conclusion. So the varsity football team has won all their games so far. If they have a game tomorrow, you might say they'll win. Does that mean they're going to win? Not necessarily, but that's the pattern that they've had so far, so we called that one inductive. Finally, a deductive example. 2 points make a line. A and B are 2 points. Therefore, you can make line AB. That's deductive, right? Just a fact like that. Now we're already up to the last thing. The last thing is a counter example. Teenagers are really good at counter examples. We love to prove someone wrong, right? Doesn't everyone love to do that? No, you're wrong. You're wrong because of this, right? You're wrong because that one time it didn't work that way, right? You can't say that. That's a counter example. Use it a lot in arguing, right? So if someone said all vegetables are green, you might be like, no, they're not. No, they're not. Carrots are not green. So carrots is a counter example. But some of them can be harder than others. If x squared is 49, does x have to be 7? Well, it does because 7 times 7 is 49, but x could not also be negative 7? Negative 7 times negative 7 is 49? Counter example. If two integers multiply to a positive, they have to each be positive. While that's true that a positive times a positive is a positive, it's also true that two negatives can multiply to a positive. So that's a counter example. Couple more. If two angles are next to each other, do they have to have the same measure? No, and I just drew a picture. Two angles there are next to each other, but they don't have the same measure. That's not always true. If two angles are complementary, if they add up to 90, do they have to be 45 and 45? They could be, right? 45 plus 45 is 90, but they could also be 50 and 40. So a counter example is just an example that proves a statement false. So we had counter example, inductive and deductive, conditional statements, hypothesis, and conclusion.